Hello and welcome to this new video. In this video, we will integrate a voice chat service for Steam. As already mentioned, Steam does not implement the voice chat interface, so we will not be able to integrate it into the game. However, to provide players with a voice chat service, we will implement the voice engine interface in this video. Unreal Engine has two different interfaces for integrating voice chat into the game: the voice chat interface, which we implemented for iOS, and the voice engine interface. In Unreal Engine, the terms voice chat interface and voice engine interface refer to two different systems related to voice communication within games or applications. The voice chat interface in Unreal Engine refers to the high-level systems and functionality related to voice communication between players in a game. This typically involves user interface and interaction. It handles how voice chat is used and managed within the game, push-to-talk functionality, volume control, or muting players. Integration with game systems. It provides developers with tools to create and manage voice communication channels within the game, such as team voice chat, proximity-based voice chat, etc. The voice engine interface, on the other hand, refers to the low-level system that handles the technical aspects of transmitting and receiving voice data. It deals with the audio capture, encoding, decoding, and transmission of voice data. This interface provides the connection to an actual voice communication engine or third-party services, and it is responsible for audio capture and encoding, capturing a player's voice using a microphone, compressing the audio data, and preparing it for transmission. Audio playback, decoding the voice data on the receiving end and playing it through the recipient's speaker or headset. Networking and transmission, managing the network communication protocols to send voice data across the network, ensuring that the voice is transmitted in real time. Integration with hardware, ensuring compatibility with different audio hardware like microphones and speakers or headsets. What's important to note is that in this video, it's up to us to manage the voice capture from the microphone, and we are responsible for retrieving the recorded voice packets to send them to the target user, who, in turn, decodes the packets and sends them for playback. The implementation is not complicated. You just need to be patient and follow the video until the end. In this video, I will show you an example of voice chat between the lobby members. You can use the same implementation to create voice chat on a dedicated server. To begin, we must first enable this service for our project. This is done in the config.ini file. We need to specify to Unreal Engine that we are going to use the voice service for our project. The variable be-enabled equals true under voice means that the voice service is enabled for our project. We need to specify under the online subsystem that our subsystem will use the voice service. Now, go to the default game.ini file. We need to specify that the session does not require a push-to-talk so that the voice service will always be active within the session. Note that this service requires the user to be in a session. Save and then close the files. Since voice chat is a common feature for all maps, I will implement it in the master player controller, so you can activate it for any level. The first thing to do is create the voice engine. We will need the reference to this engine throughout this video. So, add a custom event that runs on the client and serves to initialize a voice engine reference. You can find all the features related to the voice engine interface under Easy OSS, then Voice Engine. To add the custom event for creating the voice engine reference. We don't want to allow the creation of multiple voice engine references, so add a function that checks whether the creation of a voice engine is possible or not. Create a boolean that will be true if the voice engine is already initialized, and false otherwise. If this boolean is not true and the player is already in a session, then creating a voice engine is possible. Now, call this function to check if creating a voice engine is possible. Call the create OSS voice engine function to create the voice engine. This function returns a reference to the created voice engine, and we need to promote it to a variable since we will need it later. Call the init OSS voice engine function to initialize the engine. This function initializes the engine by specifying the number of local and remote talkers. In our case, the number of local talkers is 1, and the number of remote talkers is 1, since our lobby can only have one remote player. For now, I'll hardcode these values, but you could get the number from the game mode, for example, to make it dynamic. If your lobby can have 3 remote players, for example, you should set the value to 3 here. To avoid errors, I set a high number. Now, you need to register the local talkers. In my case, there is only the local player. This step is crucial, otherwise, the voice capture won't work for the local player. You can also unregister the local talker using the function unregister OSS voice engine local talker, but I won't be using it in this video. You can add a call to an event dispatcher here to notify you of the initialization status. Add a function in the interface that will call this custom event. Implement the function by connecting the custom event. Don't forget to set the value of the boolean to true once the process is completed. To make the voice chat functional, each local player must register the remote players in his voice engine. Otherwise, the system will not work. So, create a custom event that runs on the client and is used to register the remote players in the local player's voice engine. This event should take as input the user ID of the remote talker to register. Before proceeding, check that the engine is initialized. Call the Register OSS Voice Engine Remote Talker function to register the remote player. Add the function in the interface to execute this custom event. Implement the function by connecting the custom event. For the local player to decode and play the voice packet received from the remote talker, this player must set the playback priority of the remote talker. This is an important step. If the playback priority is less than 0, no playback occurs. Add a custom event that runs on the client and is used to set the playback priority of a remote talker. The event should take two inputs, the remote talker ID and the playback priority. First, we check that the engine is initialized, then we use the function to set the OSS voice engine playback priority. Add the function in the interface that is used to execute this custom event. Implement the function by connecting the custom event. To control the output volume of the playback, we must set the remote talker voice amplitude. So, add a custom event that runs on the client and is used to set the volume amplitude of a remote talker. This event takes as a parameters the remote talker ID and the amplitude to set, which is a float between 0 and 1. check that the engine is initialized, then call the function to set the OSS voice engine voice amplitude. Add a function in the interface that is used to execute the custom event. Implement the function by connecting the custom event. Each player participating in the voice chat must continuously send the voice packet captured from their microphone. These packets will then be received by each remote talker, who, through their role, decodes them for playback. So, add a custom event that runs on the client and is used to collect and send the local voice packets. This event must be called every tick, otherwise, you risk a gap, and the sound will be chopped up and not clearly heard by the other players. First, check that the voice engine is initialized. The function read OSS voice engine local voice data is used to read and return the voice packets captured from the local player's microphone. The returned value is a reference to the collected voice packets. It is not blueprintable. It just needs to be communicated to the remote players. Add a custom event that runs on the server and is used to receive the voice packets from the local player and then send them to the other remote players. It is the role of the server to ensure communication of voice packets between the participants in the voice chat. In the case of the lobby, the server is the host player. This event takes as a parameter the sender ID and its voice data to send. Once the voice data is collected from the microphone, we need to call the server's custom event to send it. The sender ID is the local user ID. In the server's custom event, we need to call the game mode to ask it to multicast the voice data to the remote players. I want to add this implementation in the lobby's game mode. This implementation is common for all game modes, so we can move it later into the master game mode. Before proceeding with the communication of the voice data, we first need to add the implementations to enable or disable the voice capture. In fact, no data will be collected from the microphone if the voice capture is not enabled, meaning the recording of the mic input. So, add a custom event that runs on the client and is used to start the local voice processing. Check that the engine is initialized. Call the function start OSS voice engine local voice processing to start the microphone recording. I want to display a message on the screen indicating that the recording has started. Add a custom event that runs on the client and is used to stop the local voice processing, thus stopping the microphone recording. These two events can be used if you want to implement a push-to-talk system. You can create a widget that allows the player to start and stop the voice processing. Call the function stop OSS voice engine local voice processing. Add two functions in the interface to start and stop the local voice processing. Implement the two functions by connecting the custom events. I want to proceed with the communication of the voice data. Add a custom event that runs on the client and is used to receive the voice data from the server. This event should decode the remote voice data and send it for playback. This event takes as parameters the sender ID and the remote voice data received. Add a function in the interface that is used to execute this custom event. Implement the function by connecting the custom event. In order to play the voice data, the local player must call the function submit OSS voice engine remote voice data. Be careful, if the playback priority of the sender is less than 0, the voice data will be decoded but not played, so the player will not hear the sound from the remote talker. I display the sender ID on the screen if the submission is successful. Now we just need to implement the part for sending the voice data to the remote players on the server side. I want to add a boolean that will be true if the child player controller is using the voice engine service. This will allow the service to be enabled only for levels that need voice chat. Add the tick event. In this event, we need to call the custom event that collects and sends the local voice packets. We need to first check if the child player controller is using the voice engine service. Now go to your lobby player controller. In the Begin Play event, activate the voice engine service. You must do the same in all levels that require a voice engine service. Add the tick event by inheriting the tick event from the parent. This is necessary for the parent tick to be called for the lobby level. We now need to add the implementation that communicates the voice data between players. This will be done on the server side, so we'll implement it in the lobby game mode. Go to your master game mode interface. Add a function that is used to receive the voice data from a local player. This function takes as parameters the sender ID and the voice data to receive and then multicast. Now go to your lobby game mode. Implement the function we just added. The implementation involves sending the received voice data to all players except the sender, because the local player should not hear his own voice. If you want to test the voice chat for a single player, you can include the sender in this case. We can check this by looping through the player controllers and excluding the sender ID. We send the received voice packet to each player by calling the receive voice data function of each controller. The complete workflow is as follows. During the local voice processing of each player, if a player speaks, their voice will be recorded and collected, then sent to the server, which in its role, communicates the voice data to the other players. We can now call this function in our master player controller. There are other features I haven't used in this video, such as, is headset present? Which returns true if the local player's headset is present, is local player talking, which returns true if the local player is speaking, and the unregister local and unregister remote talker functions, which can be used to unregister a local or remote player from the voice chat. As you can see, everything is done manually, so if you want to provide the player with a way to control the voice chat, it's up to you to modify the implementation. For example, muting a remote talker can be done by unregistering that talker or by modifying their priority and amplitude. To mute the local player, you can stop the microphone recording, for example. During the initialization of the voice engine, we need to automate the number of local and remote talkers instead of hardcoding them. Therefore, each game mode initializes them differently. I will therefore add them as inputs to this event. In the tick event, we need to check that the service is being used and that the voice engine is initialized before proceeding with the sending of the voice data. In this video, I don't want to create a control widget that allows the player to start and stop the local voice processing. So, to keep things simple, I call the start local voice processing once the engine is initialized. The registration and unregistration of remote talkers should happen every time there is a change in the lobby members, so on post-login and post-logout of the lobby. The problem here is that the game mode doesn't know if the voice engine initialization is finished on the client side before asking it to register or unregister a remote talker. So, here, we need to implement a pending register system instead of calling the custom event directly. There will be a timer that attempts to register the remote talkers as long as they are not registered. Add a custom event that runs on the client and is used to add the remote talker to a pending list. Call this event when the interface function is called. Create an array of strings, which represents the pending list of remote talkers to register. Once the engine is initialized, I define a timer that is used to process this pending list. Create a function that is used to process the pending list. We do not process the remote talkers if the array is empty. Call the registration custom event, passing the first element of the array. Once the registration is done, we need to remove that element from the list, otherwise, the registration system will loop on the same talker all the time. In this video, I do not unregister the remote talkers. If you implement an unregistering system, you need to create a similar pending system to the registration. Just like I did for starting the local voice processing, to keep things simple, I call the implementation of setting the playback priority once the registration is done. You can create your own widget to control the playback priority. Priority 0 is the highest. I give 0 to all remote players. Similarly, I set the amplitude of the remote player once his priority is set. I consider in this video that the lobby voice chat is not a push-to-talk system, so I leave the local voice processing active and stop it in the end play event of the child controller. In the lobby game mode, the implementation of communication for the voice data can be moved to the master game mode, so it will be common for all game modes. Otherwise, you will need to copy it into each game mode that supports a voice engine service. Select the implementation and then copy it into the master game mode. It can now be removed from the lobby game mode. Our system is complete. We now need to request the creation of the voice engine for each player connected to the session, and then ask it to register the remote players. Go to the On-Player Controller Ready function. Just to remind you, this function is called once a player is connected and their controller is ready. What we will do is call the initialization of the voice engine for this connected controller. For my lobby case, I have a single local player and a single remote player. This implementation will work for the connected remote player, not for the host, because the voice engine initialization requires a valid session. This function runs for the host when they open their lobby before creating a session, so we need to duplicate this implementation to also run once the lobby session is created. In the case of a dedicated server, you don't need to duplicate it since all the controllers connected are clients of a valid session. Now that the voice engine is initialized for all players, we need to call the registration process each time a client connects to register the remote talker. This process is similar to the registration of players in the session. What we will do is duplicate this function to register the remote talker for each member of the session. The only difference is that we should not register the connected client as a remote talker in the player controller of the connected client because for him, he is the local talker, but for the others, he is a remote talker. Duplicate the function. In the master player controller, in the registration implementation, we need to check that the talker ID to register is not equal to the local player ID, so we avoid registering the local player as a remote talker. What we will do now is call the registration process for each controller to register the list of player IDs. Go back to the onPlayerControllerReady function to call this function. I forgot to give the name of the function to the timer for registering the remote talkers. I add a message on the screen to indicate that the registration of a remote talker is complete. Everything is ready to start a test. Launch 2 clients to test the implementation. Create a lobby session on player 1 side. We can clearly see the message, Start Local Voice Processing. Join the session from player 2. Once in the session, we can clearly see that player 2's voice processing has started, and player 1 is registered as a remote talker. On player 1's side, player 2 has been registered as a remote talker. If you start talking, you should hear your voice since the test is on the same machine. You should also see the voice data received message on both players with the remote sender's ID. If you see the message but hear nothing, make sure the priority of the remote talker is properly set. You might experience a delay since the test is in the editor, and it's not the same performance as a package game. If you don't see any messages related to the voice engine, make sure you have properly activated and configured the service in your configured INI file. To activate the service for another level, such as on a dedicated server, you simply need to copy what we've done in the lobby player controller and in the lobby game mode. In this video, I've implemented a basic system. If you want to control the voice chat, such as rooms and muting, it's up to you to play around with the implementation. As you can see, the local voice processing is stopped for both players because we started the match, so the end play event has been executed correctly. That's all for this video, see you in the next one.